Okay, so the last question of this test part, which is question B5 on page 35. So B5. Okay, so let me read the question, page 38. Give examples of polynomials p of x, g of x, q of x, r of x, which satisfy the division algorithm and then specific conditions under the subheading 1, 2, 3. Okay, one by one we'll do. Now we have to satisfy the division algorithm. Write it once. Dividend p of x is equal to divisor g of x into quotient q of x plus remainder r of x. This is the division algorithm we have to be mindful of as we do this. So subheading 1 let us take. And there's subheading 1, the other condition is, besides satisfying the algorithm, division algorithm, we have to satisfy this condition, that is degree of p of x should be equal to degree of q of x. Okay, so let me explain to you what is meant by degrees of polynomials. So you can please write it down, degrees of polynomials. Degrees of polynomials. Degrees of, write it down on your notebook. This is important, okay? To understand what is the degree of a polynomial, even though I've told about it now and quite a number of times in your previous test, let me explain in detail once more. Now, in simple terms, okay, degree of polynomial means this. A, let us say, we have a constant number, let us say 7 or 5 or minus 2, whatever. Let's take two examples together because that's easier. X plus 7 or x plus 5, up to you. Now, what is the highest power of x here? Yes, you see only 1 and the power is not there, means plus 1. So the power of x is here, plus 1 means the degree of this polynomial is 1. That's the meaning of degree of a polynomial. Okay, so the polynomial x plus 7 has degree 1. Now here there is no x, so there is no power of x, so that's why we call degree of constant number as 0. Okay, they are also called constant polynomials for convenience. Okay, then let us say we have here x squared, the third example, plus x plus 1. Just taking random examples. Highest power of x here is, yes, plus 2, so the degree will be 2. So in other words, degree of polynomials means the highest power of the variable of a polynomial. The highest power of the variable means usually x, because x is commonly used, even though not always, sometimes t squared, but x is the highest power of the variable, usually x, that is taken as the highest power of the variable in all the terms of a particular polynomial is taken as its degree. Okay, so now question is saying, I will say here now something. Now, according to question condition, degree of p of x should be equal to degree of q of x. Okay, and this will happen only when, okay, let me just use when g of x is a constant. That's fine, you don't have to think too much, I'll explain it down here. Okay, so the question will go back to question. Give examples of p of x, g of x, q of x, r of x. P of x, g of x, q of x, r of x. So we have to give 4 polynomial examples. So we have to give that of p of x, so just write it down. Then g of x, then q of x, then finally remainder r of x. And we know this is dividend equal to divisor in the quotient plus remainder, the division algorithm. Now let us look here now. So g of x should be constant. Let's just put it and I'll explain it. Constant means numbers like 2, 3, 4, 1, whatever. Any number will be taken as constant. So maybe we can put 4. I chose 4, but you can choose whatever number you like. Why should it be like this? Let me just write here. Now, Let's put p of x. In this case, we can just put it. So 4x squared plus 4x minus 16, let us say. So I chose 4. Let us put p of x first. And then because 4 is dividing all this, I'm just taking 4. Then what happens? P of x divided by g of x, because p of x is dividend, means the numerator is called dividend, and g of x divisor means denominator. So when you do this, you're going to get 4x squared plus 4x minus 16 divided by g of x 4. When we put these two like this, g of x constant and p of x something like this, and the g of x divisor constant, then only we're going to get p of x degree equal to degree q of x. This one will come out same degree with this. Let's just check out. So here now, which is equal to, okay, let me do it here. 4 common factor, so take it out, x squared plus 4 outside, so here inside x, plus into minus, minus 4 into 4, then only 16 divided by 4. So this 4 and 4 cancel. So you're going to get equal to here x squared plus x minus 4, which is equal to q of x, the quotient. Let me explain to you this by this. So let us say we divide 4 by, or let me take a different number, 6 by 3, like this, p of x by g of x, p of x by g of x. Then you divide, then 3 2s are 6, 0 remainder. So the question is, whatever you get after cancelling, 3 2s are 6, this one. So after cancelling, what is left is the quotient, as you can see. So this is the quotient, q of x is the quotient. So here now, you're going to write here, okay, so you're going to write here, that is q of x. Now what is q of x? This one, so you write it here, q of x, x squared plus x minus 4. So when we put p of x, choose a particular polynomial and divide by a constant number that is cancelling exactly, then you're going to get same degrees here. Highest power of x of p of x, yeah, degree is 2. Q of x also degree 2. That happens only when you divide by a constant, means when you put g of x as constant. That's what we mean it. Okay, so here we got like this. Okay, so now we can write it down here. Therefore, finally again we can write it down. Therefore, final analysis, p of x we have chosen equal to 4x squared plus 4x minus 16, and g of x we intentionally put it as a constant number. Then we got q of x on cancellation of these two. We got q of x here, x squared plus x minus 4, and the two have same degree here, and then q of x and r of x, exactly dividing here numerator and denominator 1 means no remainder, so r of x will be 0, where, okay, where we can say degree, condition of the question, p of x, we know, go back, p of x, highest power of x is 2, so degree is 2, and degree, next q of x, let's check, is also equal to, when we do that, divide a given chosen p of x by a constant g of x like 4, then our q of x is coming out, highest power of x is 2, so the degree of q of x also 2. So they are, p of x and q of x have same degree. So in other words, that is degree p of x is equal to degree q of x. So the condition of the question that the degree of p of x should be equal to the degree of q of x is satisfied. Then the question is also saying, go back to question, which satisfy the division algorithm. So we're going to check for that. So right up to here to there, and then I'm going to wrap up this one. Now the division algorithm is left hand side p of x dividend, right hand side g of x into q of x plus r of x. So let's just take the right hand side. Now g of x into q of x right hand side of this division algorithm equation plus r of x will be equal to g of x, our choice, go and check, 4 into q of x here x squared plus x minus 4 plus r of x here 0. So continue doing it. 4 into x squared, 4x squared, plus into plus, plus 4 into x, 4x, plus into minus, minus 4 4s are 16 plus 0. So here 4x squared plus 4x minus 16 plus 0, it can be neglected. Now look at this, g of x into q of x plus r of x. Finally we got 4x squared plus 4x minus 16, which is exactly the same as this, which is p of x. So we can just write here p of x. So we have proven g of x into q of x plus r of x, this one, is equal to p of x. We find that our choice of p of x, g of x, q of x, r of x is satisfying the division algorithm. So we can just write here which satisfies the division algorithm. So algorithm, so this one, first question. The second one, we'll go to the second one. Okay, the second one is question B5 subheading 2. There is given degree q of x, this time degree q of x should be equal to degree r of x. So remainder and quotient should have same degree. So let us write here should have some degree. So just write here p of x, let us choose, then g of x, q of x, r of x. What we're going to choose, we have to, each of these three questions are not going to be same pattern. Okay, we have to improvise, and sometimes it's easier to take p of x first and go to g of x. Sometimes it's easier to choose these three first and go here last. We're going to do that. Okay, so degree, looking at this condition, which one will, from where will start and end, will be determined by this top condition. So degree of q of x, this one, and r of x should be same. So I can just randomly put degree of q of x, x plus 5, then highest power of x is 1, means degree is 1, so degree is 1. Then I have to, since degree of r of x should also be same, I should put here same degree, x minus 2, let us say. Now I've chose here x plus 5, you could have put x plus 4 also. So let me remind you, question number 5, 1, 2, 3, none of our answers are going to be same. Mine, yours, and other persons are going to be different. But then if we follow this condition, our answers are all correct. Okay, these are not fixed answers now. Now degree is 1 for q of x. Degree of r of x is also 1. So we have satisfied the condition. So we're starting from here because the condition is here. That's what I meant by we are having to improvise. Okay, differently, improvise in a different manner in each of these questions. Now once we are through with that, then there is no condition given for g of x. So you can just put anything you like. But before that, now I put here this one. Suppose somebody chose x squared plus 5. And you wrote here x squared minus 2 or minus 3, whatever. Q of x, x squared plus 5, x squared minus 2. That's also correct because degree here 2, that of q of x, and degree of r of x is going to be 2. Then also the degree is equal. Like this also you can do. That's why I'm saying it's not going to be fixed answer. Okay, I hope you're getting it. But let's just keep it simple. I'm putting degree 1 because degree 1 polynomials are easier to deal with. Okay, then g of x, there is no condition, so just put any polynomial like x plus 7 maybe, or let us say x plus 3. Let's just put x plus 3. Okay, then don't worry about the p of x. So here you write where degree, showing that we have satisfied the condition of the question. Degree q of x, here highest power of x is 1, so the 1, and degree r of x, here also the highest power is 1, I think. r of x here remainder. Highest power of x is 1, so 1. So both q of x, r of x have same degree 1, 1. So in other words, I'm saying degree q of x is therefore equal to degree r of x. According to the choice that we have made, we have satisfied the condition of the question, first part. Then to get p of x, go back, we have to satisfy two conditions. Degree q of x equal to degree of r of x, which we have satisfied. Next satisfaction is we have to satisfy this algorithm, division algorithm. So let's take the right side. Why? Because you see here we have three things: g of x, q of x, r of x. G of x, q of x, r of x, the values we have chosen. Then if we take this and solve, we're going to get p of x. So don't do p of x in this case first. Though in the first question you chose p of x first because it was convenient to do so under that particular condition. Okay, so right side of division algorithm is g of x into q of x plus r of x. So that will be equal to simply g of x, go up and see. We have chosen x plus 3. As I said, you could be choosing x plus 7 also. Nothing wrong as long as you're choosing a polynomial. Okay, then as I said, so we are not going to get same answer. Q of x here. X plus 5 plus r of x here. X minus 2. G of x, x plus 3 into q of x, x plus 5 plus r of x remainder, x minus 2. So we're taking the right hand side of the division algorithm and just solving it simply. So this will multiply these two first, plus into plus, plus x into x, x squared, plus into plus x into 5, 5x. Then here, we have multiplied both these, now go here, plus into plus 3 into x is 3x, plus into plus 3 5s are 15. Then to remove this bracket, you can just multiply plus into plus x, plus into minus 2. Now we can deal with this one, so that you're going to get here equal to x squared. So we're coming from here to here. Plus 5x plus 3x is plus 8x, plus 8x plus 1x is plus 9x. So the like terms we have added. Then 5, 8, 9. Then here plus 15 minus 2. Bigger one, plus 15 minus 2 means subtraction. So 3, so plus 13. So you're going to hear here plus 13. Right, so plus 13. So that we know that this one should be equal to p of x. So you just write here equal to p of x. Then only the division algorithm is going to be satisfied. So p of x, you have chosen this one now. So we have no choice for p of x. We have to compulsorily put x squared minus, plus 9x plus 13, and only then it will satisfy the division algorithm. So you write here which satisfies the division algorithm. Okay, division algorithm. I hope you're getting it. Now you see here. So this one here, g of x, q of x, r of x. Let me check once more. X into x, x squared. X into 5, 5x, 3 into x, 3x, 3 5s are 15, x minus 2, x squared plus 8x plus 9x plus 13. Yes. So number 2 done. So our choices of p of x, g of x, q of x, r of x are these. And they will surely satisfy degree of q of x equal to degree of r of x and the division algorithm. The third one and the last one. Okay. So let's do that. The third one is B5 subheading 3. Let me read the question. Degree of r of x. Now, degree r of x this time should be equal to 0. Now, we know degree of r of x will be equal to 0 only when r of x is a constant number. Because degree of a polynomial is 0 only when it's a constant number like 7, 5, 2. So you can just choose here now. Therefore, p of x, we don't know here. g of x, q of x, r of x. Let's choose now. R of x is compulsorily a constant, because only when it's a constant, let's say 5, then the degree will be 0, right? You could have chosen 2, 3 also, up to you. Okay, now once you're through with that, the rest there's no condition, so you can just put your koshi. Q of x can be p of x can be last. No, g of x, don't put p of x plus 7, x plus 5, let us say, or x plus 5 and maybe x minus 3, whatever, or x minus 2. That's right. So randomly you can put, because there's no condition for that. On this one cannot be random fully. It can be random in the sense that you can choose any number, but it has to be a number. It cannot have x, because the moment x comes in, the degree will become 1 and the degree should be 0. Okay, so now we have these three: g of x, q of x, r of x. So we can make use of this to get p of x. So you write here, before that, let us show we have satisfied the condition here. Degree r of x. As see, constant number means the degree is 0. So satisfied the condition. So right side of the algorithm, g of x into q of x plus r of x. Right side, what you're going to get, because we have see here g of x, q of x. So we're taking advantage of what we have chosen already. So g of x is x plus 5. Okay, x plus 5 into q of x is x minus 2 plus r of x is here 0. So we can just multiply x into x squared plus and minus x into 2 is 2x and plus and plus. Now 5 will multiply this to 5 into x is 5x plus and minus is minus, 5 2s are 10 plus 0 we can neglect it. So next we're going to get equal to x squared minus 2 plus 5. So plus 5 bigger, 5x minus 2x. Plus minus means subtract, 5 minus 2, 3. Bigger one plus, so this 3 will have plus sign. You can write that on your graph if you want. So minus 2x plus 5x is plus 3x. And here minus 10. So that has to be equal to p of x. So you just write here equal to p of x. Then only, so p of x has to be this compulsorily, x squared plus 3x minus 10. Then only division algorithm is satisfied. So which satisfies? Once we put it here as p of x, this one, then we can surely say which satisfies the division algorithm. Okay. So that concludes the part for test 2.3b. Now you can go and give the test. Okay.